It's 1944, deep behind the Western Front. In a cold, damp evaluation shed, a German ordnance engineer named Klaus picks up a captured American submachine gun. He almost laughs. This is the M3? It looks less like a weapon and more like something cobbled together from plumbing pipes and scraps of sheet metal. Grease gun, the Americans call it. The name fits. It's crude, ugly, almost an insult to his craft. Klaus is a man who understands precision. He knows the tight tolerances of the MP-40, a masterpiece of German engineering. He's studied the American Thompson, the one this M3 is meant to replace an expensive, beautifully machined weapon in its own right. But this thing, it feels like a toy. He scoffs, then pulls back the charging handle. The bolt slides with a gritty, unrefined clatter. He feels the simple, stamped receiver, the spot welds holding it all together. There's no fine milling here, no hand-fitted parts. It's a product of a factory, not a workshop. He takes it to the range, half expecting it to jam on the first magazine. But it doesn't. It just runs. A steady, monotonous asterisk, thump, thump, thump asterisk of 45 caliber rounds hitting the target. It's not elegant, but it is undeniably effective. And a chilling thought begins to form in his mind. The Thompson cost over $200 to make in 1942. This M3? About $20. They weren't just building a gun. They were building it by the million. The pride he feels in German precision begins to curdle into a quiet unease. He sees a different kind of genius at work here, a brutal, efficient logic that prioritizes quantity over craft. This unsettling feeling crystallizes when they bring him the M1 Garand. This isn't a specialist weapon for stormtroopers. This is the standard issue rifle for every single American infantryman. A semi-automatic. While German soldiers are still working the bolts on their carabiner 98 kiloseconds, every GI has the firepower of a self-loading rifle. Klaus strips it down, his trained hands moving with practiced efficiency. He's stunned. No tools. Not a single one needed. The entire weapon disassembles with just a bullet tip and his fingers. The parts are rugged, interchangeable, designed to be fixed in the mud and rain by a teenager who was a farmhand 6 months ago. He imagines the sound of it on the battlefield, a sound his comrades are already reporting with dread. 8 rounds fired as fast as a man can pull the trigger, followed by that iconic metallic asterisk ping asterisk as the en-bloc clip ejects. That ping, it's not just the sound of an empty rifle. It's the rhythm of American industry. A constant, relentless beat, signaling that another 8 rounds are ready to be loaded. Germany has captured these rifles, of course. They call them the Selbstledegewehr 251, but they can't copy its spirit. They are trapped by their own obsession with perfection, with hand-fitted parts and minuscule tolerances that a speck of dirt can defeat. The Garand represents a seismic shock to his entire philosophy of war. If this is what the Americans give to their average soldier, what other horrors have they simplified? He thinks of the reports about their anti-tank weapon, the Bazooka. It's little more than a steel tube, a wooden stock, and a battery for ignition. An almost laughably simple idea, yet so effective that Germany is already rushing to create a larger, more powerful version, the Panzerschreck. They are copying the crude idea because it works. Klaus looks back at the grease gun lying on the bench. He sees it differently now. He sees the stamped steel, the simple blowback mechanism, the sheer, unadorned utility of it all. Is this ugliness a form of genius? A genius that doesn't care about beauty or tradition, only about putting a functional weapon into a soldier's hands as quickly and cheaply as possible? Is this industrial might, this tidal wave of simple, effective tools of war, about to overwhelm a culture that worships beautiful, deadly complexity? His hands, accustomed to the precision of a Swiss watch, now traced the rugged lines of American machinery. He measured, sketched, and compared, his brow furrowed in a mixture of confusion and dawning respect. This wasn't primitive. It was a different kind of brilliant. He laid his blueprints of the German MG-34, a marvel of milled steel and tight tolerances, next to the American Browning M1919. Where the German gun was a symphony of complex machining, the Browning was a testament to pragmatism. It had fewer operations, looser tolerances, and parts that seemed almost crude by comparison. Yet, it worked. Every single time. Then he turned to the M250 caliber. Madus, as the GIS called it. Its parts were massive, almost agricultural in their simplicity. The locking mechanism was brutally straightforward. There was no delicate fitting, no gunsmith's final touch. It was designed to be assembled and to keep cycling. Whether it was caked in mud on a Jeep-mounted pintle or freezing at 20,000 feet in the wing of a P-47 Thunderbolt, this wasn't just a gun. It was a universal component. His notes grew more frantic. He saw how American designers had waged a war against hand-fitting, that final, time-consuming process of making unique parts fit together. They forced interchangeability into every corner of the design. They created an entire ecosystem of production, complex jigs and go-no-go gauges, ensuring every part was within an acceptable range. They used captive pins that couldn't be lost in the field, simple coil springs instead of machined flat springs, and subassemblies spot welded together in seconds. Even the finish, a dull gray parkerizing, was faster and more durable than the deep, beautiful bluing of European arms. Crates of spare parts arrived at the front, each one a testament to this philosophy. Inside were standardized spares, clear, simple manuals filled with diagrams and components that shared the same screw threads across different weapons. An armorer could fix a machine gun with parts from a different factory, thousands of miles away. It was an ecosystem designed to be soldier-proof. The numbers he jotted down were staggering. The M3 grease gun, a crude-looking submachine gun made of stamped metal, saw its production time and unit cost plummet compared to its more elegant counterparts. It cost about $20 to make, less than a quarter of a German MP40. The M1 Garand, the standard issue rifle, was produced not in the thousands, but in the millions. And the M2 machine gun? It was bolted onto almost every vehicle in the Allied arsenal, from tanks and half-tracks to ships and aircraft. A single, reliable solution to 1,000 different problems. The engineer's initial shock was turning into a profound unease. This wasn't a lack of sophistication. It was a redirection of it. The genius wasn't in the finished product's polished elegance, but in the stamping dies that could punch out a receiver in a single blow and the carefully calculated tolerance bands that allowed for mass production without sacrificing reliability, and in a design ethos that prioritized maintenance simplicity above all else. Then he examined the bazooka. It was stark elegance in its purest form. There was no complex sighting system, no exotic propellant. It was a tube, a simple battery circuit to ignite the rocket, and a warhead. It was the kind of weapon you could teach a farm boy to use effectively in a single afternoon. The strategic implication hit him like a physical blow. This philosophy, this relentless pursuit of simplicity, created speed. Speed allowed for unprecedented scale. And scale, on the modern battlefield, meant overwhelming firepower. He closed his notebook, the scent of cosmoline and Parkerized steel thick in the air. Now he needed to understand what this industrial philosophy meant out there, in the mud, and the snow in the terror of combat, where every complex, finely tuned machine was just one grain of sand away from becoming useless dead weight. The forest is a graveyard of steel. Here, in the hedgerows of Normandy, and now in the endless green hell of the Hurricane, the war has become a relentless, grinding machine. Statistics, once cold numbers on a page, now have a sound. It's the sound of 8 rounds firing as fast as a man can pull a trigger. The steady, hammering rhythm of the M1 Garand. I watch from a captured trench as an American squad advances. 10 rifles, then 20, then 100, all laying down a wall of semi-automatic fire that our boys, with their slower, bolt-action carabiners, simply cannot match. It's not a duel. It's a deluge. The air thrums with the constant asterisk ping asterisk of ejected clips, a sound that has come to mean another 8 rounds are on their way. Above it all, the heavy, syncopated thunder of Browning. 50 calibers from their tank-mounted rings tears through the trees, chewing up earth and wood and hope. I move forward with a reconnaissance team to inspect a roadblock we thought was secure. It's been breached. A knocked-out half-track sits smoldering, its front armor peeled back like a tin can. The culprit lies nearby, a simple steel tube, dented and scorched, a bazooka. As I examine the crude but effective weapon, I watch 2G's retrieve it. One of them nonchalantly wipes it down while the other pulls a fresh rocket from a canvas bag. In less than a minute, a weapon that just crippled a 500,000 Reichsmark vehicle is ready to fire again. The sheer disposability, the brutal efficiency of it, is staggering. Our Panzerschreck is a superior weapon, technically. But they have thousands of these, with rockets to spare for every squad. The disparity continues in the workshops. I remember a Panzer IV in our company, a beautiful machine, but its commander's sight was damaged. It took our mechanics 2 days to get a replacement, and another half-day of careful hand-fitting to make it work. Just yesterday, I watched an American armor crew pull a damaged machine gun from their Sherman's hull mount. They jogged over to a supply jeep, grabbed a new one from a wooden crate, and slammed it into place. The whole operation took less than 10 minutes. Every gun is the same gun. Every part is the same part. Their system isn't built on perfection, it's built on interchangeability. This morning, we bypassed a Panther, one of our finest, sitting motionless at the edge of a field. Not battle damage. A failed final drive, a known weakness. A masterpiece of engineering, immobilized by a single overstrained component. Meanwhile, a whole battalion of Shermans rumbled past it on the adjacent road, churning the mud. They are inferior tanks in a one-on-one fight, but they keep moving. Their good enough reliability becomes an overwhelming force when multiplied by the 1,000. They don't need the best tank. They just need more tanks on the line than we can disable. It's the small things that truly haunt me. I see a young GI, barely a man, perched on the muddy fender of his Jeep. He's field stripping his Garand with a casual intimacy, using the rim of a spare cartridge as a tool to pry a pin loose. He does it without thinking, a motion repeated 1,000 times. Later, I find a captured American ordnance pamphlet on the floor of a blasted-out command post. It's not a dense technical manual. It's filled with simple line drawings and plain, direct language. A manual for a farmer, not an engineer. They've made maintenance an intuitive act, accessible to anyone. The shame is a cold weight in my gut, but mingled with it is a reluctant, burning respect for the enemy's philosophy. This isn't just warfare, it's industrial theory put into practice. Just an hour ago, I stood at the edge of a captured supply depot. A truck had just arrived, and soldiers were unloading crates. One broke open, spilling its contents onto the muddy ground. Hundreds of identical, gleaming steel bolts for the M3 submachine gun. The American supply sergeant overseeing the work just picked one up, wiped it on his pants, and grinned at his men. He didn't need to check it. He didn't need to measure it. He knew with absolute certainty that every single one would fit. I watched him, and for the first time I felt the cold certainty of defeat. The proof wasn't just in the factories back home. It was right here, in the mud and the blood. The war ended not with a bang, but with a quiet, almost clinical tour. I wasn't in a camp. My skills were too valuable. Instead, I found myself escorted by polite American engineers, their uniforms crisp, their faces unreadable. They wanted to show me something. A look under the hood, one of them said with a wry smile. We drove for hours until we reached a colossal brick building, humming with a low, rhythmic power, even in its post-war stillness. This, they told me, was where they made the M1 Garand. Inside, the scale of it was staggering. It wasn't a workshop. It was a cathedral of production. Gone were the rows of master craftsmen, each at his own bench, patiently filing, fitting, and finishing. In their place stood gargantuan stamping presses, silent now, but looming like iron gods. An American major, a man who looked more like a factory foreman than a soldier, walked me down an aisle. He pointed to a press. "One stroke," he said, his voice echoing slightly in the vast space. "One stroke and we have a trigger housing. How long would that take in your Oberndorf tool room?" I didn't answer. I knew the answer. Hours of a skilled man's life, milling and drilling from a solid block of steel. Here, it was a matter of seconds. He led me to an assembly line. Bins overflowed with identical components. He picked up a bolt assembly, then a receiver. With a practiced motion, he snapped them together. No tapping with a small hammer, no dressing with a fine file. It just fit. "Our secret isn't better steel," the major continued, his tone matter-of-fact, not boastful. "It's this," he gestured around us. "Fixtures, gauges, simplicity. We can take a farm boy from Iowa who's never seen a lathe, and in 2 weeks, he's part of the line, checking tolerances with a go-no-go gauge. 2 weeks. It took us 2 years to train a journeyman gunsmith, a tradition stretching back centuries. They had replaced our artisans with a system. The numbers were a physical blow. Over 4 million Garands. Hundreds of thousands of the simple M3 submachine guns, the grease gun, they called it. Tens of thousands of the Browning M2, each a masterpiece of heavy firepower. I thought of Minister Speer's frantic late-war memos, his desperate calls for standardization, for rationalized production. We were just beginning to explore what they had perfected. Our stamped MP-44s, our crude Volksturm rifles, they were a desperate, dying imitation of a philosophy the Allies had institutionalized from the very beginning. We had been fighting a war of craftsmen against an army of industrialists. I walked over to a pallet stacked high with trigger housings, still slick with protective oil. I ran my fingers over the smooth, pressed steel. The corners weren't sharp and precise like our milled parts. They were rounded. The surfaces weren't mirror-polished. What I had once dismissed on the battlefield as cheap and crude American manufacturing, I now saw with horrifying clarity. It wasn't cheapness, it was genius. Every radius was designed not for aesthetic perfection, but for the curve of a cutting tool, for the life of a die. Every tolerance was intentionally widened, not out of sloppiness, but so the gun would function when filled with mud and grit. They hadn't designed a rifle. They had designed a rifle, the soldier who would use it, the depot that would repair it, and the factory that would build it, all as one interconnected system. My entire professional creed, the pursuit of perfection passed down through generations, crumbled in that moment. The old faith that the best weapon was the one made with the most skill and the finest finish was a lie. Or at least an irrelevant truth in the face of this new, brutal law of wartime engineering. The goal wasn't to create a perfect object. It was to put an effective object into a soldier's hands in overwhelming numbers. I stopped before one of the largest stamping presses, a silent monolith of green-painted iron. I placed a hand on its cold, massive frame. And as I stood there in the quiet of the factory, I could almost hear it. Not the hum of its motor, but a different sound. A distant rhythmic thunder. The sound of millions of rounds being fired on 1,000 fronts. The percussive beat of a war we never truly understood how to fight. The rhythm of the machine that had defeated us. The war was over, for me at least. The interrogations were predictable. The Allied officers, with their polite but firm questions, wanted to know about our wonder weapons. The jets, the rockets, the Maus tank. They expected secrets, some spark of Teutonic genius they had somehow missed. I watched them, listened to their questions, and the truth, a truth I had spent years desperately ignoring, finally settled in my gut like cold lead. It wasn't about genius. Not in the way we thought. I remember one captain, a young man with calloused hands, probably an engineer himself before the war. He asked why our Panther tanks, magnificent as they were so often found abandoned on the side of the road. Why our Sturmgewehr 44, a rifle years ahead of its time, never reached enough hands to matter. He wanted to know about metallurgy, production quotas, the science of it all. But the answer wasn't in the blueprints. It was in the philosophy. We designed masterpieces, I told him, my voice hollow in the sterile room. You designed tools. The words hung there, simple and devastating. Our engineers were artists, obsessed with perfection. We crafted the Tiger tank like a fine watch, with intricate overlapping road wheels, a marvel of precision engineering. A marvel, that is, until it met the Russian winter, and mud froze solid between those beautiful wheels, immobilizing the beast completely. We built the Me-262, the world's first operational jet fighter, a machine that could have swept the skies. But its Jumo 004 engines had a service life of maybe 25 hours. A few glorious flights, then a complete, costly overhaul. We saw a problem and engineered the most elegant, most advanced solution imaginable. The Americans? They saw a problem and engineered the most practical solution. They looked at their expensive, beautifully machined Thompson submachine gun and asked, how can we make 1 million of these yesterday for a farm boy who's never held a gun before? The answer was the M3 grease gun, a crude, ugly thing of stamped metal and simple welds. It looked cheap because it was cheap. It was also reliable, easy to fix, and they could churn them out like sausages. While we were hand-polishing gears for a single Panther transmission, they were loading thousands of grease guns onto ships. Look at the M1 Garand. Before the war, every army believed semi-automatic rifles were too complex, too delicate for the common soldier. America just did it. They gave every single infantryman a reliable, rapid-firing rifle. They didn't just give them a new weapon. They fundamentally changed the nature of a firefight. A squad of GIS could pour out a volume of fire that our bolt-action-equipped soldiers could only dream of. It wasn't magic, it was a decision. A decision to prioritize firepower for the many over perfection for the few. Even their Browning M2 machine gun, a design from the 1920s. We laughed at it, old, heavy, uninspired. But it worked. It worked in the freezing air over Europe, it worked in the sands of Africa, and it worked in the jungle humidity of the Pacific. You could bolt it to a plane, a tank, a jeep, or a tripod. It was everywhere, a testament to rugged, dependable design. When their soldiers needed a way to kill a tank, they didn't form a committee of physicists. They took a rocket, put it on a tube, and called it a bazooka. It was so brutally simple and effective that we copied it to create our own Panzerschreck. We were seduced by our own brilliance. We designed for the ideal scenario, for the skilled operator, for the clean workshop. We created a logistical nightmare of 1,000 different parts for 100 different vehicle variants. The Americans designed for the worst-case scenario. For the terrified 19-year-old in a muddy foxhole, for the overworked mechanic with a greasy wrench, for the factory worker who just learned to use a press. I spent years perfecting a single gear, convinced its flawless meshing was a form of victory. I was wrong. I mistook mechanical beauty for strategic superiority. True elegance in wartime isn't a complex transmission. It's a rifle that still fires when it's caked in mud. It's a tank that can be fixed with a hammer and a prayer. It's the weapon that gets to the battlefield in the first place. I think back to my workshop, to the gleaming, fractured gear of a Panther's final drive lying on my workbench. And next to it, I picture a greasy, simple M3 submachine gun. One, a broken jewel. The other, an unbreakable hammer. In those two pieces of metal, right there, is the entire story of how the war was won and lost. The machinery of war is filled with these hidden decisions, these quiet turning points where a simple choice of metal or manufacturing changed history. There are so many more stories locked inside these designs. If you want to uncover them with me, subscribe for more untold stories from World War II.